here. Once again, I am in front of you to discuss the rest part of the Planck's quantum theory. It is not the rest part of Planck's quantum theory, but it is an explanation by the Planck's quantum theory on the black body radiation and photoelectric effect. Black body radiation is already explained very early. So, few of the points which were remaining in the during the explanation of photoelectric effect by the Planck's quantum theory, we are saying. So now the Planck's quantum theory, the third point of the Planck's quantum theory, which explains that if the nu is greater than nu naught, means this is the frequency of the striking photon or quantum, and this is the threshold frequency. This is the threshold frequency, means the minimum frequency required to eject the electron, that is the nu naught, and this is the total frequency of a photon or the quantum falling over the metal surface. So if you say that this nu is greater than nu naught, then what will happen? First of all, that if nu is greater than nu naught, that means the frequency of the falling photon, frequency of the falling or striking photon or striking quantum, if it is greater than the threshold energy of that metal, then if you increase the intensity, that means if you increase the brightness of the light, if you increase the brightness of the light, if you increase the brightness of the electromagnetic radiation, then what will happen? The number of quanta incident increases. Then what will happen? First of all, the condition is that if the frequency of the striking photon or quanta is more than the threshold frequency nu naught. This is the first condition. If this condition is maintained, after this condition or over this condition, under this condition, if you increase the intensity of light or electromagnetic radiation, that means if you are increasing the brightness of light, if you increase the brightness of light, then what will happen? Number of quanta or number of photon will increase. Number of quanta or number of photon will increase. And you know that one photon eject one electron, two photon will eject the two photons. So if the per second number of photon or quanta increased, then the number of electron ejected per second will increase. So if you increase the intensity of the brightness of the light, then you are increasing the quanta or the photon or incident of that light which is striking the electromagnetic radiation is striking the metal surface. So when you increase, then you are increasing the number of photoelectrons, because you know that the number of electrons are directly proportional to the number of photon or quanta. As you are increasing the number of photon, number of quanta, and that's why there will be increase in the number of photoelectron. If you increase the number of photoelectron, then the current will increase. So number of ampere will increase in the circuit. So that's why if the frequency of a light which is falling over the surface is greater than the threshold frequency, and in this condition if you increase the intensity of light, brightness of light, then you will get a higher amount of current, because it will release more number of electrons, because it releases more number of photons or quanta in it. Okay. Now the next point, that is the last one, that is the fourth point we are discussing. Even in this case, first of all, the same condition, that the frequency of the incident light, frequency of the striking light of photons, if it is greater than the threshold frequency, and if you further increase the frequency, it is already, that means it is already, the frequency is already greater than the nu naught. Already the frequency of the light already greater than the threshold frequency. And if you further increase the frequency of the incident light or incident electromagnetic radiation, then what we will do? If you increase the frequency, then there will be rise in energy. There will be rise in energy. Okay, there will be rise in energy because energy is what? H nu. Energy equal to H nu. So you are increasing the nu. So that's why the energy is increasing. When the increasing is, then each of the photon will have more energy. Each of the photon will have more energy. When you increase the frequency, then each photon will have the more energy, and to eject the electron, only the threshold energy will be utilized. Only the threshold frequency will be utilized. The rest of the frequency, rest of the energy will be utilized as a kinetic energy for the electron. That is why if a frequency is already greater than threshold frequency, and in this condition you are still increasing the frequency of the striking light or striking electromagnetic radiation, then it will increase the energy of the electromagnetic radiation. When you increase the electromagnetic radiation, it will increase the kinetic energy of the ejected electron, because to eject the electron only the threshold energy is required. So whatever the excess quantity of energy is produced here, that will be utilized the kinetic energy. So the movement of photoelectron will become fast because it will get at a return more amount of kinetic energy into it. Okay, and this observation we have depicted as a graph. You can see this graph along the y-axis kinetic energy of the emitted electron is depicted, and along the x-axis the frequency of the light has been depicted. And this is the nu naught, so this is the threshold frequency, because up to this frequency it is utilized for the ejection of electron. Once the electron is ejected, it needs kinetic energy, so whatever the frequency you are increasing, that will increase the kinetic energy. You can see in this graph, we have taken the different frequency and different kinetic energy, plotted a graph, and you can see the graph we are getting a straight line. We are getting a straight line graph. A straight line graph. This straight line graph indicates that there is a rise in kinetic energy linearly. Kinetic energy increases linearly once there is a direct relation. That means the kinetic energy is directly proportional to the frequency. That is why we are getting this graph. So it is depicted in the graph. Kinetic energy increases linearly with the increasing frequency. That means kinetic energy is directly proportional to the frequency. If you increase the frequency, there will be direct rise in the energy. So this is depicted here. So now we have concluded the Planck's quantum theory, explanation by the Planck's quantum theory as well as explanation of the Planck's quantum theory. And after explaining all these things, we come to the conclusion. So before this Planck's quantum theory, I have utilized the Maxwell's wave theory of radiation also. So we are not rejecting the Maxwell's wave theory of radiation, because the certain properties could be explained by the Maxwell's wave theory of radiation. Certain properties are explained by the quantum theory. So we have to study together. So what is the conclusion now? That we should study Maxwell's wave theory as well as Planck's quantum theory. When these two theories club together, we get a modern theory. Okay, so we should know the modern theory. So modern theory is what? It is a combination of the Maxwell's wave theory of radiation and the Planck's quantum theory. So when you combine these two theories, then only you will be able to explain all the properties of electromagnetic radiations as well as light. Light is also like part of electromagnetic radiation. So we talk separately light because something it is in the light. Something is visual, everything is visual. That is why light is more important. That's why every time we take the example of light. But what is that? It is also a part of the electromagnetic radiation. It is one of the electromagnetic radiation. Light is one of the electromagnetic radiation. So when you look at the Maxwell's wave theory radiation as well as the Planck's quantum theory of radiation, then you will find that this electromagnetic radiation or light has got a dual character. It has got the wave-like character, it has got a particle-like character. Now you can see, so the light and other electromagnetic radiation has both the wave nature as well as the, what is wave nature? You have already seen the phenomenon of diffraction interference. It is already explained to you. Earlier topics we have explained in physics. You know the what is diffraction, what is interference. This diffraction and interference could be explained when we consider the Maxwell's wave theory. Because before Maxwell's wave theory we used to consider the Newton's theory. So Newton's theory got failed over there because Newton's theory always considered everything as a particle. Newton's theory always considered everything as a particle. So with the particle behavior we were not able to explain this phenomena like diffraction and interference. So we have introduced a Maxwell's wave theory. So Maxwell's wave theory could explain the phenomenon of diffraction and interference. So it explains that light or other electromagnetic radiation has got the wave character. Now forget the Newton's law. Now we have got another theory, quantum theory. With that help we can explain the particle behavior also. Because due to the particle behavior only, all the electromagnetic radiation, whether you take the light or any other electromagnetic radiation, it gives the black body radiation and photoelectric effect. This black body radiation and photoelectric effect could not be explained by the phenomenon by Maxwell's theory as well as Newton's theory. So both the theory, Maxwell's theory, Newton's theory, both got failed to explain these two, black body radiation and photoelectric effect. But it is explained by the Planck's quantum theory, Planck's quantum theory of radiation. So we should clear. So Planck's quantum theory of radiation again confirms the particle behavior as it is used to said by the Newtons that things have got a particle behavior. So this particle behavior again confirmed by the Maxwell's quantum theory. Okay. But Newton say that it is a particle behavior, but the Newton's law does not explain these two characteristics like black body radiation, photoelectric effect, and certain more things are there which is not required here to discuss. So now when you consider this theory, Maxwell's wave theory as well as the Planck's quantum theory, then we will say that each and every radiation, all the electromagnetic radiation, whether it is light or certain other, all will have a dual nature. Dual means दो तरह का nature. Dual nature means दो तरह का nature. Has dual character. That means it will behave as a wave as well as particles. So this is the conclusion of the Maxwell's theory and the Planck's quantum theory. So we come to the conclusion. So now this topic got over. So now for atomic structure we will be discussing Rutherford model, Bohr's model. You have already got the introduction of all these models in our previous classes. So now we will study it in advance. Okay, it's an advanced concept. And to discuss these theories, particularly for the Bohr's model, we need certain things. We need to study before going into the details of the Bohr's atomic theory. We need certain knowledge about certain thing, which is called a spectrum. So that is why I am just introducing the atomic spectra. So Bohr's model is based on the atomic spectra. Therefore, before moving into, we shall study about the spectrum. So what is a spectrum? What is a spectrum? It is a band of colors. So spectrum is nothing, it is a group or band of wavelength of colors. It is a band of wavelength of colors. You have seen the rainbow. You have seen the rainbow when the sunlight falls over the water droplets into the atmosphere during rainy season. When this sunlight falls over it slanting, not slanting at a particular angle, then due to the total internal reflection, this sunlight first there is a total internal reflection and there is a diffraction. Okay, and due to which we get a rainbow, band of 7 colors. Band of 7 colors. One color merges into another. At the top there is a violet, at the bottom there is a red. Okay, so there is a band of 7 colors. This band of 7 colors is known as a spectrum. And here what is happening? In this band of color of the white light which we are getting from the sun, there all color merges into one another. There is no clear-cut boundary between the colors. One merges into another, one merges into. Nobody can say what is the boundary of this here. Yellow color, red color, violet color, what no, nobody can say. So this type of spectra is known as continuous spectra, in which one color merges into another. But in case of atom also we get a band of colors, but their band of colors comes with a well defined boundary. We will say that this color started here and here, it started here and here, it started here and here. So there is clear cut distinct boundary of the colors. Again it is a band of colors, but in this band of colors, boundary of the colors are defined clearly. It is depicted clearly, and that is why we say it as a line spectrum. It is a line spectrum. So we will, or this line spectrum is known as atomic spectrum, because such type of line spectrum is given by atoms only, no other things. Only atom can give you the line spectrum. No other things can give you the line spectrum. So that is why the line spectrum has got another name, atomic spectra. That is the characteristic of the atom. So just I have introduced to today the spectrum. Next day I will discuss it in detail. So today I will discuss that. So, and the science in which we study about the spectrum. And the science in which we study about the spectrum, that science is known as spectroscopy, where we study about the emission spectra, absorption spectra, when there is emission of energy, emission spectra, when there is absorption of energy, absorption spectra. Spectrum is spectra, that is band of colors arranged with one another, stacked with one another, that is called spectrum. Okay, so we will study next day. So the splitting of light into series of colors, that is called dispersion. That series of colors band is called spectrum. So we know that dispersion, due to the dispersion we see that. Okay. Next we will discuss the spectrum in details. Thank you. Have a nice day.